like I was at page A, I was at page B, I did this like C, and you try to follow this like chain of things, and your app doesn't crash, and you just kind of start shaking your head and get really, really frustrated. So basically, at this time, you go back to the client, you say, I can't reproduce it. They say, well, we're reproducing it, and eventually, you're stuck on it whether you want to do it or not. So here you go. We're on memory leaks now. So do we have a memory leak? There's a fairly easy way to know if you have a memory leak. You can perform some of the steps I'm going to show later, or if you play with the app long enough, you'll get something like this. Basically, Xcode or whatever you're using, say terminated due to memory error, and in the console, you also got a ton of received memory warnings. So in this case, yeah, you definitely have a memory issue. So now we get to the good stuff. How do you actually find a memory leak? So there's two different ways. Basically, show of hands, who here has seen the Chrome timeline tool? I think most of us. Okay. Who here fully understands what the Chrome timeline tool is? So this is the problem I've noticed with a lot of tools is there's a lot of data, and trying to make sense of a lot of different lines and graphs and like I think we all have like a kind of roundabout knowledge of like what it's actually doing. So let's just follow it for a quick second. So we have listeners, which is the amount of listeners on a page, or like any action you perform, things happen. So that's that. Nodes are like the amount of DOM nodes and stuff we have. So things like an HTML div or something. Documents, I don't know, we can ignore that. And JS heap is the actual size of the amount of memory you're currently using. So if we follow this, this is over time how things are actually like interacting. So strictly what we really want to follow is this blue line. And with garbage collection, actually, show of hands who here knows what garbage collection is. So I'm going to go over that really quickly. It was what half. So the way JavaScript works is you allocate memory. So it's like any programming language. Memory is allocated. It's stored into a heap. And basically, eventually, when that memory is no longer being used, you want to clean that memory up. So there's two types of cleanup methods. And the two types vary. So one type is like, it's really quick. And it happens really frequently. Depending on the different garbage collector you're using, some things are generational. If it tries to clean up something and it doesn't clean it up right away, it puts it into pot B, so it tries to clean it up less. So there's a lot of different methods. That you can see right here, I think these little jagged lines, the little ones, this is where like memory is being deallocated anytime this goes down. And then you have something called a mark sweep. A mark sweep is pretty standard across most browsers. So it starts at the top nodes, goes all the way down your program in the heap, and finds everything that needs to be deallocated. So these are really, really costly. They take a lot of time, and they happen infrequently. So you see this giant jump down? This right here is a mark sweep. So right up here, another one, another one. So if you want to see if you actually have a memory problem, we want to actually watch this blue line over time. So over a short span of time, it's okay if it goes higher and decreases. That just means more memory is being used before it's been cleaned up. But what we do care about is over a span of time, if this, is that blue line going back down to where it should have been. So we start down here, and then we do some things, and we start over here. And this is just me navigating between some pages. So if I come back to that initial page, this blue line should still be down there, but it's gone higher. So we're using more memory than we are expecting to. So we have a memory problem. Okay, so there's also another thing in Chrome that, show of hands, who here has used the Profiles tab? Okay, cool. So there's three different things. JavaScript, CPU, profile, not really applicable to what we're doing today. We have Heap Snapshot, record, heap allocations. I'm going to go into depth with those. So record heap allocations. It's kind of a cool tool. Over the span of time, much like the timeline profile, you can kind of see how memory is doing over a span. So if I start in point A, and I do a bunch of things on the keyboard, I hit finish, point B, this is the result. This is what's happened. So I can see the amount of objects that have been allocated, the retained size and their shallow size. So again, you can kind of see up here, allocation and merge sweep. So, but this doesn't really tell us too much information. So as I said, one of the common problems with trying to figure out how to solve these issues is that there's so many tools, but they don't really help. I'm going to go further into that after. I've had a very nice talk with Firefox, the memory profiling team, who created their tools on Tuesday. I'll get to that at the end. So basically, there's another thing. I'll do that right now. Sure. So if you take a heap snapshot, instead of using the profiler heap allocations, like recording, so we're going to take a snapshot, you can actually search at the top in summary. So it kind of does the same kind of thing. It's a point A time. It's not point A between point B. It's purely like, at a given time, what do I have? So if you actually search through the different types in summary, you can find all the different objects that have been allocated. You can find system objects, you can find array objects you kind of done prototypically yourself. But there's something really, really neat, and it's called detached DOM tree. Okay, does anyone know what a detached DOM tree is?
It's DOM objects that don't belong to the actual view and as to existing memory.
Exactly. So these can be okay. Like Angular uses some detached DOM trees occasionally for like directives and stuff. But if we look at this and we go, okay, so these are all the DOM nodes that have been taken out of the actual DOM tree, but are still saved in memory. Okay. What happens when I go between two pages consistently and I see this DOM node? This is the same distance, so it's the same. Imagine it's the same collection of DOM nodes. We see it increasing like 148 DOM nodes. Does anyone know what I think this means? You want to try to guess?
You're creating DOM nodes in JavaScript, not attaching them to the DOM, but not clearing them out of memory.
Exactly.
There's still a reference to them. So.
Yes. So over time, so this is like kind of like the heap allocation thing I was showing. This is like an over time. So I have point A, point B now, and I can see that my DOM nodes are increasing over time. And I mean, if you can see memory is increasing over time, like you have an extra 10 megabytes when you shouldn't have that memory, and you see DOM nodes increasing over time, generally that's a good indication of this is actually somewhere you should start. Because this is HTML, this is information that's being saved, that's not being dereferenced. So that's a leak in itself. So what you can actually do is you can open these up, and you can actually see the HTML that's being leaked. So this gives you a really, really good clue into where the leak is actually happening. I'm going to go into that a bit further later. The other one is just if you take a bunch of heap snapshots, as I was saying, you can actually see the memory increasing over time. So if you see that and it's not supposed to be increasing, like your user hasn't performed a user action to add new information into the application, then that's bad. So with all these tools and everything that we've seen so far, I ran into an interesting problem, and especially with enterprise applications, there's so much data, like unbelievable amounts. Like if I go back to this thing, you can actually see like there's 3,700 objects in like the arrays, right? And like look at the number of objects that are. It's like look at the amount of data that there is. How am I supposed to determine what's bad, what's good? All I know is that there's a leak because the memory's been increasing. How am I supposed to track it down? So as of right now, the tools in their current state are not very set up for this. It's just the current state of affairs with like memory profiling tools. There's so much data, and there's not any really way to narrow it down. So if you see your memory increasing, and you know that it's been increasing because you've been going from page to page, and that shouldn't happen that way. I found the actually easiest way to do it is start cutting your code in half before manual search. to remove half of your code, is the problem still there? It is? Okay, start removing half of that code. And I know this sounds silly, but it's actually the easiest way I've come across. Like, if you go through this attached DOM nodes and you compare all those DOM nodes and you find the 122 extra DOM nodes, you've already spent like 2 hours comparing 500 DOM nodes. I mean, realistically, it's just a waste of time. So here's what I meant. If you go to these DOM nodes, you can go in and you can actually open that up, and you can open up this HTML element and come down. It gives you the class name and everything else associated with it. So if you want to spend the time of like 2 hours comparing all these DOM nodes, unless your app is smaller, then in that case it's probably worth your time. But if you have a big app, it's just a little unwieldy. So, I mean, we're going to get into like the Firefox thing I was discussing. So, as for actual leaks, leaks are all different. I mean, it could be one of a million things. You could have event listeners. Does everyone know what an event listener is? Okay. Imagine you attach an event listener onto a DOM node, but you change your page and that DOM node is supposed to be removed, but you never removed your event listener. That DOM node stays in memory. Or you have Google Maps, a third-party library, and you instantiate it, but you leave, you come back and reinstantiate it. Say Google Maps is not supposed to be reinstantiated. So there's another memory leak. It could happen in third-party frameworks, basically anywhere. I mean, memory leaks all have something in common, and that's that they're not cleaning up after themselves. But other than that, it's pretty random. So this is just some tips for, I have a demo for you guys to go through and basically find memory leaks in an application. So we'll go through that. So some of the problems with single page apps is they destroy and recreate a lot of information between pages. So there's scoped information, the objects aren't the same, and when you're diffing to heap snapshots, it's just a completely new set of information, even though it's contextually the same information. So yeah, when you're trying to figure out memory leaks, it ends up being a little time consuming, but it's not that scary. All right, so let's just go over to this firstly. So I was talking with Firefox, and I spent a good hour on a conversation with them, and we basically went over the current state of memory tools. And they added in something where you could figure out where memory is being allocated functionally, which is cool. It's awesome. You could be like, oh, this function is allocating like, I don't know, 2 megs of data. Like, that's an issue. But in a large application, you have 8,000 functions all creating data. And just because something's creating data doesn't mean it's bad. So then you can diff 2 snapshots, but then still it's 8,000 functions. How do you really determine what's good, what's bad? So we came up with something that's called, well, they have it in their Bugzilla. It's an automatic leak detection based on regression modeling. So what I mean by this is you have like snapshot A, B, C, D, E, F, G. You have like 10 of these. And what you do is you actually look for patterns. Memory leaks are generally linear. So over time, the memory is increasing. And this will start picking those out for you on a functional basis, which is awesome. But this is just an idea as for now. I mean, it's in their system, but it hasn't been created yet. Also, tagging functions, doing some kind of like decorator thing so that you can be like, oh, I really only care about the information being allocated out of this function. And then you could basically sort through all the information from top down of what's been allocated there. So I'm going to take questions, but I created an application with 3 leaks in it. And I was going to hopefully go through this with you and see if you could all figure out where the leaks are. So I feel like that's a good kind of step towards learning how to find memory leaks. So his show of hands who hasn't set this up yet. Okay, 1, 2, 3, 4, 4. Has everyone else set this up so far? Yeah? Okay. So do you want me to can you read that? It's github.com, Harold. zoom it up a little bit. That didn't help. Okay, concert coder / leaky - ionic - app. So it's a very simple application. I'm going to run it. Does anyone need that up there still? Is everyone good? Okay. So the first 15 minutes, I was just going to do a quick presentation on how to figure out where the leaks are, and now the last 45 minutes, we're actually going to try to figure out where the leaks are. I figure this will take us about 45 minutes. So here we go. So it's a very simple app. I'm just going to give you a walkthrough so we know what we're dealing with. It's basically a playlist editor. So these are a bunch of bands. I used to use RDO, and they kind of dissolved, but they let me export all my music. So I use that as a base of 10,000 different artists. So we have a pretty good set of data. Thank you, RDO. I miss you. Okay, so we have a bunch of artists. Let's go into one of them. Chick Chick Chick. Does anyone here know Chick Chick Chick? They're awesome if you don't know them. They're like kind of like funky, groovy, kind of West Coast noisy punk. It's cool. Anyways, my ping. Let's go inside. So now we can see their albums. Here's all their albums. And let's go into an album. So here's all the tracks. Let's try to play a track. Well, we can't play a track because I don't have licensing rights. So don't try to play the tracks. All right. Now if we go to playlists, so there's a menu bar. Playlists, artist search. So artist is where we started off. So you go to playlists, you can add a playlist, give it a title, call it Chris's playlist. Add it. It's right there. Has no tracks. Go to artists. Let's go to one of the albums. Swipe it over. So if you swipe it, you can add it to a playlist. Choose the playlist. Go back to playlists. There's one track in there, the one I just added. Very, very simple app. There's also a search. So if I type in the word alone, it comes up with all the tracks as well as artists and albums. This is kind of pointless because you can't really do anything other than search. But I mean, I added it in just because the app needed a bit more substantial. So, okay. Who here, does everyone have like their gulp serve up? Does anyone not have the app up right now? I can come help really quick if you need me. Almost done? Okay, cool. Good. Everyone's good? Okay. So let's start. So I guess I can give everyone a starter point. Start over on, let's say, tracks page. So I'm going to give you a hint. This is the first one I'll give you a hint on. There is an issue in the tracks page. It's an easier one to start off with. So go to the tracks page, open up your console tools, and let's go over to take a heap snapshot. By the way, if you click this little garbage thing, it clears up your GC right away. So I would advise before you take heap snapshots to click that little garbage thing. Did everyone see that? Or yeah, cool. So let's take a heap snapshot. It's 18.9 megabytes. Okay, cool. Let's go away from the page. So the scope gets destroyed. Let's come back to the page. And let's clean up the garbage one more time. All right, it's 19.2. I'm on the same page. It's increased by 0.3 megabytes. Let's try that one more time. Well, 19.4, still increasing a bit. Clear it one more time. 9.5. Let's do that one more time. 19.7. Okay. So over a span of 5 snapshots, we can see on the same page it's almost increased almost a megabyte. And this has been the same page, so this shouldn't be happening. So this is a memory leak. And if we go look at the detached DOM nodes I was talking about earlier, we sort them by count. We'll see something here. All right. So right here, you can see it starts off, and look at the top one. You see where it starts off where it's 16? Now it's 18? Do you want me to make the screen bigger? Here, hold on. There we go, cool. So it starts off with 16. Let's make this a little bigger. Maybe still bigger. This is kind of annoying. Okay, that's better. So it's 16, then it's 18, then it's 20, then it's 22, and then it's 24. So we can see there's actual DOM nodes not being cleaned up. So this is another really good indicator that there's an actual issue. All right, so let's open up the code. Let's come in. I'm using Sublime, but you can use whatever you want. And let's go to that page. So I started this really simply. I don't know, show of hands who hasn't used Angular before. Okay, so it's cool. So basically it's set into a bunch of different folders. Right now we're just going to focus on sections. This is on a per page basis. So if you go into sections, you have the album section where you're actually viewing the album, the artist, create playlist. It's all broken down on a per page basis. So where we know there's an actual issue is under the album. So here's the HTML. We're actually displaying all the tracks. Make this a little bit bigger. And here's the controller. So a controller is basically just where all your code for this page goes. All right. So does everyone want to try figuring it out?
Sure.
Hmm?
Sure.
Yeah? All right. No? Does anyone want to start deleting code?
Oh, yeah, you're good. It's probably in the
Oh, thanks.
callbacks.
Does anyone want to come up with me? Start deleting code?
He's looking for a volunteer.
I'm looking for a volunteer. Does anyone want to help me try to figure this one first down out?
Sure.
Come up.
Oh, all right. I don't know Angular very well.
Oh, it's cool. Don't worry. We're just deleting code. That's all we're doing. Good. So right over here, this is what we're dealing with. This is where we know the page has an issue in this album. So it's basically, think of it right over here. This page right here.
Mm-hmm.
This is the album page. Mm-hmm. And then here's this control over here. So what should we try first? Should we try deleting the HTML or some JavaScript?
It's interesting, HTML. I hadn't thought of deleting HTML. I would start with JavaScript.
Okay, let's start with the JavaScript. Okay. So should we just delete all of it? Or?
I would highlight, I would comment out probably 80% of it and start there.
Okay.
So like establishing the variables up front, those probably, yeah, some of those. This is Sublime, yeah.
So you can just delete it. We won't do it there. Okay, cool. Let's save that. All right. So we've commented out most of our code now, most of our logic. Let's see if the issue is still there. So we're going to reload this page. Come back to artists. Clear this up. Go back into here. Let's use them up. So we're going to use Thriller as the example in this one, okay? So let's go between these two pages. So let's do the first snapshot. So go to timeline first.
Yeah.
And always clear it up. So we're going to clear up the GC.
Why do we do that?
So we're always clearing the GC to make sure that it flatlines back to where it was. If you don't, then when you take a heap snapshot, it might not be as low as you think it is. Let's go back to the bottom. Let's really clear up the GC again.
Yeah.
So we're going to clear the GC again. We're going to go back. We're going to do this. Cool. Try that one more time.
36.
So this is something we have to keep in mind when we're doing this, is just because there's an increase, doesn't always mean it's a bad increase. Applications still leave some kind of footprint occasionally. If you have like a history manager,
So that might be a bad
did you clear
increase.
GC? That might be a bad one. You did?
Yeah, but we can do it again.
Try clearing it one more time.
Back, and then thriller, and then timeline, clear, profile, and snapshot.
Oh, it's the same. Okay, do it one more time. So the thing about this is it's a fairly manual process. Occasionally your memory is not the same, occasionally it is the same. It doesn't mean it's a leak. This is why you have to take a lot of snapshots and try to find trends. And it's 1.1 again, 1.1 again, 1.1 again. So we got rid of the issue, but in order to verify we got rid of the issue, search for, on the bottom one, detached. And do that on all of them and sort them by object count. So we're going to go look at our friend detached DOM nodes one more time, and we're going to see if they're increasing still. All right, and
9, 29, 29.
they haven't been increasing. So we solved our first memory leak. Well,
Sort of.
sorry, we didn't solve it. We know that
Identify it.
that's where the memory leak exists. So let's go look at that code.
So, yeah.
You can go sit down right now if you want.
Oh, okay.
So I mean, that's just the process of like figuring out where a memory leak exists. I mean, he did it really, really quickly, and that only took us, what, maybe 5-10 minutes? I mean, that's better than searching through like countless amounts of memory to try to figure out exactly what's going on. So let's look at this. So most of the people here said that they actually know some Angular. So who here has used Ionic model from template before? Okay. So what do you have to do when you're finished with an Ionic model?
It's been a while.
Does anyone know? Okay, so let's look at this code really quick. We're using Ionic model from template URL. Let's go to the web. Let's go find that. Oh, it's Ionic model.
Call remove on it.
That's fine. Wait, who said that? What'd you say?
Call remove on it when on the destroy.
Exactly. So if we look right here, on destroy, you're supposed to delete it. And if we look at our code, what aren't we doing?
Just say goodbye and that's it.
We're not removing it. We're not deleting it. It's still existing in memory. We're not cleaning up after ourselves. So this memory leak we can blame on ourselves because this is the code we wrote. So this is where it gets more interesting. Is memory leaks don't only have to exist in the code you've written. How can we trust all third-party libraries? We can't. It's just code. I mean, it's just like another person like you or I writing these things. And this isn't exactly a practice that everyone goes and looks up, is their memory footprint the exact same that it should be? All right. Who wants to try to figure out the next one? Can I get another volunteer?
I had a quick question, Angular. So how does that mechanism work? Is it through callbacks or through event listeners when you hook up the models in Angular?
Oh, with this?
Yes.
The fact that it's leaking? You want to know what?
No. I understand the removal of it. So
Yeah.
when you connect the callbacks, is it an event listener or is it just a callback that you connect to the other object? Or
Oh, so this creates a model,
Yep.
and then you put the model on the scope. So
Okay.
this model is like a bunch of, I don't know, it's data, like DOM nodes, whatever.
Yep.
Now it's over here. But when you try to remove this thing, those DOM nodes still exist on the scope. So the scope can't get deleted because those DOM nodes are still existing on the template, or like on the HTML. When you try to remove it, it just keeps this and it keeps the scope.
Even though it's not there.
Exactly. All right. You want to try to figure out the next one?
No? Yeah, what's the next one?
So I'll show you the next page where the one exists. We could try to figure it out on your own laptop, or someone wants to come up, or I can just show you.
I'll come up.
You'll come up? Awesome. So let's put this, and let's fix this while we're here. Want to fix it? So if you want, I have the page this open, so you can like just copy the destroy thing if you want to put it in. Yep. So we're gonna put that in. We're just gonna fix it.
It's Command C, isn't it?
Yeah, sorry. I just put that in wherever. Yeah, press that in, and just put VM model. Right there. So just put VM instead of scope. I'm on the second thing. Right now. Cool. Okay. Yeah, VM. Yeah, that's fine. Cool now. All right, so that problem's solved now. And let's try to figure out where another page where another issue exists. So let's go back to artists. And let's try on another page. Let's start on search. So I'm just going to give a little tidbit of information. I'll tell you where there isn't an issue, because the best way to figure out where there is an issue is going between a page that there isn't an issue and a page that there is an issue. So that way you can actually see if memory is increasing. So if you have kind of like a baseline, I usually normally use a blank page for this. So I wipe off everything on a page, and then I go back and forth between that page and another page, and I'm like, this blank page is definitely okay. This page might not be okay. Oh, this memory is increasing. Okay, cool. So in this case, we're going to use the playlists as our blank page. So this one is clean, I promise. This one, we don't know. Let's find out. All right. So clear the garbage collection every time and take Heap Snapshots.
All right. I'm not sure.
Oh, you don't have to
So
use
we're
search.
navigating
Yeah, we're just going to navigate.
between artists and
Go to playlists,
playlists.
and then go back to search. So playlist is clean for sure.
Alright.
Search maybe not. Oh, finish. Finish. Click clear at the left. Yeah, that thing right there. And then click the GC. So it's the garbage thing.
Totally on the wrong one. I was thinking.
Okay, cool.
All right.
So now we've cleaned our garbage collection. We're going to take a snapshot. Go ahead. All right. Just wait for it till it's done. Okay. Now go back to playlists. Go back to search. Clear it.
There.
Yeah. Using that. Yeah. And try again. Okay, so it looks like it's maybe increasing, but we don't know yet, because sometimes the app increases memory. Sometimes it's JIT code. If you guys know what JIT code is?
Just in time.
Yeah, just in time code. Sometimes it creates the code and then it doesn't remove it in time, and then basically your app is increasing by like a megabyte worth of memory, but it's actually not gonna, it's gonna go away. So we're gonna keep trying this a few times. Okay, still looks like it's increasing, and try to do it 2 more times. Still increasing. And last time. Still increasing. Okay. Can you do me a favor and search for the detached objects? And sort those by object count. Yeah, just do that for all of them. So let's see if there's an increase. Okay, now scroll through them, let's see if they're increasing. Does it look like they're increasing? Yeah, show of hands. Is it increasing? Do we have a problem? All right, we have a problem.
So if you expand a bunch of stuff, I can't really.
Yeah, so we can expand that, yeah. So you have one of those and expand it again. And you could put a cursor over that comment if you want. Just cursor over it. Just wait. The preview's not available. Try a different one. So the thing is, sometimes things get cleaned up, but not fully. So let's go through and check out one of these ones. Check out one of those. So we're going to check out another one that's still growing. Not available. Check out the div. Okay, let's check out another div. Okay.
You're gonna find one.
Let's check the DOM tree above this one. 21.
I'm sorry. Down tree above this one?
Yeah.
Really?
Should I want to let's check this one. There you go. So right here you can see some information. It's an ion item. But again, like we could scroll through and we'd have to figure out of the 20 items what's actually getting leaked. So we'd have to do a manual comparison from the first one to the last one and figure out which items aren't the same. So let's just try clearing some code. So yeah, where's the code? Oops. So yeah, we're on the search page right now. Search. Let's look at the controller, and let's look at the HTML. So where do you want to start, HTML or controller?
I'm not sure yet.
Where does everyone want to start? Do we want to start on the HTML or do we want to start in the controller code? We'll do a show of hands. Controller code, show of hands. 2 people, 3 people. Okay. HTML, show of hands. Okay, majority is HTML. Okay, so let's rub out.
Let's try that.
What'd you delete?
Oh. I'm not used to this command.
Oh, no worries. Here. I'll do it. All right. So how much HTML do we want to delete? All of it? Half of it? What should we try deleting? Anyone?
Let's delete those ion items.
Those ion items?
And 7.
Sure. So we want to delete this ion list? Okay, let's try that. Save it, we'll go back, and can you take more heap snapshots now?
All right.
So clear it, and then just the same thing. So let's find out. Let's find out if that fixed it. Try again. Try clicking the garbage one a few times just in case. Yeah. I always click it like 7 times. I find if I click it once, sometimes it doesn't work. I'm not exactly sure. I might just be superstitious on this, but.
Oh, it's gotta be, because like hard refreshes don't
Yeah.
always work.
Okay, now go again. Do one more. There you go. Get in the hang of it.
All right. So it's gone away?
Okay, so maybe let's check the detached DOM nodes. Yeah. And let's go for all of them.
31, 31, 31.
So now go sort through them. Yeah. Now let's go through all of them. Let's see if there's an increase in anything.
17, 11.
Cool. So it looks good. So this is what we get. It's a false positive. So we think we've actually solved it. But if we actually add some more stuff in, that's not this. That's not the actual problem. So this is where things actually end up getting really tricky. This is where it gets really crazy. So I'm just going to tell you that the issue is actually an ion spinner. So this is what blows my mind. So because of the way Angular is set up, just like this is an Angular specific thing, is that Angular uses doubly linked lists. Okay? So go back to your snapshots and look up scope. Actually, I'll do it. No, it's not increasing, is it? Nice. Okay, so Angular uses doubly linked lists, so that means the children know about the parents and the parents know about the children. So if you have a piece of code that is leaking, then that can affect the parent, which will then affect the children. So the reason why it looked like the ion list was leaking is because something else on the page was affecting the ion lists to leak.
Yeah.
So if you add another directive here instead of ion list, that would start leaking. So if we get rid of this ion spinner, also I want to show you ion spinner. Yeah, so basically this was a problem in a much earlier version of Ionic. I am using an earlier version for the sake of this demo. There was an actual problem with the ion spinner, so it's been solved since. But yeah, if we get rid of that, and we keep that HTML that was there, it's cool, I know. Want to do it again? Yep. We'll do it again, and the problem will still be gone. Yep.
Well, what's causing these memory?
So specifically for the ion spinner, I can show you if you want, but it was.
I guess what I'm interested in is like top 10 or top 3 or something. What typically is it that you're looking for?
It's just missing cleanup. So in this case, a controller was being created for the scope of the directive, and the controller itself was created in the directive. It wasn't like done through Angular magic. So the controller needs to be deinstantiated, so it needs to be destroyed, but it was never being destroyed. So because that controller was still there, it was basically affecting things up and downstream.
Okay. But that's really specific to Angular.
Yeah.
Whereas any framework is potentially going to have memory leaks.
So a lot of memory leaks are caused by, and like from what I've seen, basically event listeners being put onto things and not being taken off when you're done. So you have a bunch of like JavaScript code that it's a class and it like creates some stuff and some HTML and it attaches some like DOM nodes, attaches some event listeners to the DOM, and then when you destroy it, it clears up most of itself, but it leaves the event listeners, and then those DOM nodes, like whenever they get destroyed, stay in memory. So that's one of the biggest things. Also, like misusing things like Google Maps. If you use instantiate Google Maps more than once, it's just more memory gets put into the global scope.
And actually, Google Maps is a very good case for a good use of detached DOM, because whenever you use Google Maps, you should put it, should create a reference to it that will be preserved between your views.
Yeah.
So that when you go back to a view, you reattach this node to your current view.
Exactly.
As far as I can tell, it's the only way to.
There's another hacky way to actually dereference Google Maps, but the Google Maps team has said you're not supposed to. You're supposed to create a Google Map once and just keep it alive for the entire time. So
It's the fastest way.
it is. Also, recreating a Google Map can take time. So you got to reload the maps, you got to do everything like that. So if we look over here, I'm just going to look at the detached DOM nodes. We had a pretty good run there. It's still gone. So in this case, it was the ion spinner. So much time we got? We got 15 minutes. So there's one more left. Can I leave everyone here to try to figure it out right now? Someone raise their hand when they think they've got the other one. So remember that if you need a clean page, the playlist page is clean. Also, the search page has an issue on it, and the album track page has an issue on it. So as long as you avoid those two sections, then you know that you're not doubling up on your problems. If anyone needs help, I can walk around and help someone try to figure it out as well if you want.
Which page is left?
So you have multiple pages left. I mean, I said the playlist is fixed. So it's either this page, the artist page, or the album page. One of the two. And if someone doesn't want to try to figure out what it is in the meantime, I can answer questions about memory leaks in general if you want, well, just to kill time.
What sort of memories do you see that are not related to detached dump trees and that are still trackable?
So in the way we built our enterprise application, you have scope. So sometimes your scope objects don't get destroyed because they still have information under them that aren't being dereferenced properly. So it's that whole doubly linked list issue.
What about like timeouts and intervals and stuff like that? Like I've seen problems. I mean, maybe it's not like a typical memory leak, but like where somebody's checking for something or whatever, and they forget to either set a max interval count or they're not cleaning up. They're using maybe polluting the global scope or whatever. And
Yeah, that's also an issue. That's also not cleaning up after yourself, right?
Yeah.
So it's generally not cleaning up after yourself. So yeah, that's definitely a possibility. You can use something like, in my project, we were using streams, something called RxJS. Has anyone here used RxJS? Yeah. So another danger with RxJS is, I mean, a lot of your, if you're doing kind of like a flux pattern, you have your services with stores, and they're emitting these streams that basically broadcast data, and you subscribe to these streams. And these subscribers get put onto like this like kind of global-ish store, and because they live in services which are like single. So if you subscribe to these things, but you don't unsubscribe to these things, eventually, you know, your memory increase will like also be apparent. So that's also another case of not cleaning up after yourself. It's just make sure you clean up after yourself. Is that any other
I have a
questions?
question about the Mozilla stuff.
Sure.
Do they intend to try to actually like build some diff behavior into it to tell you which functions, like which are new and which have changed? Or
So I can show you something. Let's go open link. So right here, this is a bug they found in the Mozilla world under Bugzilla. So it's not like there's a feature or a story. So implement automatic leak detection. So this is based on a white paper done in Java. So Java's already implemented this as called Quark. I can open that up if you want. So this is Quark, and basically it's dynamic leak detection for Java. So you take like 10 snapshots, and it basically finds, it does like regression modeling over the data allocations. So it finds data allocations that are increasing but not coming back down. So that way, if your data, like, you know, data is pretty in flux. Like your data is never usually linear over like point A to point B. It can jump up and down depending on the pages that you've been to. But over a span of like 10 snapshots, you get a really, really good idea. So this is the white paper they're basically going to base their implementation on. Does that answer the question?
yeah, I'll go read it.
Okay, cool. Yeah, it's in the slideshow if you want it.
Do you have more details on how to use the differential view in snapshot profiles? Have you ever used it?
Which, in Firefox or Chrome?
In Chrome.
Okay, yeah, so let's go over. So what you can do, right here, you can go comparison between this 1 and 3, right? So let's get rid of that. Right here, so this is the problem. It's needle and a haystack syndrome. This is like the way I quote the current state of profiling tools is there's so much memory. We have 2,000 deleted, 2,100 new. We have a delta. We have like a massive allocation size, a read size, a size delta, and we don't have a memory leak. This is actually without a memory leak. So how are we supposed to find out if we do have a memory leak? That's why I basically came up with this super manual method of doing it.
Yeah.
As long as you can see a trend happening with your memory increasing, you know it's there, and then just kind of narrow it down. If that makes sense. Yeah?
Just not a question, just a note. Our QA guys are getting really excited about this thing called Monkey. That just like basically
Oh yeah, I know Monkey.
randomly clicks on your app.
Yep.
I want if we could combine that with that manual process somehow, that could make an automated tool that does what you were showing that Java
They
thing.
can show if you have memory leaks. Yeah, absolutely. You could even do that with what's that other automation tool that you can use for testing? It, like
Selenium?
Selenium. You can even do it with Selenium. Because with Chrome, if you go into the console and you go, I think it's performance. What we got in there? Oh, here it is, memory. Perfect. So if you go into window.performance, memory, JS heap size, limit, and then total JS heap size, you actually have access to the current state of memory. So if you had Selenium running, you could just get the current state of memory and start logging that, and keep coming back to that page after like multiple actions. And if there's an issue, you could probably see like a linear increase in memory. So you could definitely build a tool. So, I mean, I left it into the hands of the Firefox team.
Sure.
But if someone wants to build that, I mean, it's totally doable, and that would be an awesome like tool too. Yep.
What about events that don't get removed?
Yep.
Like how do
I find this?
yes. Do you have an example in your app maybe? Or?
So events, 99% of them get attached to DOM nodes, right? So if events are getting attached to DOM nodes, and you're going between those pages, those DOM nodes aren't going to get cleaned up. So if you go to detach DOM nodes, you'll actually see the DOM nodes increasing. And then once you know that they're increasing, you've kind of located by switching between two pages, right? So then you can go in and delete like half your code or whatever, or you'll see the event listener you haven't cleaned up.
What about the other ones, events that are not attached to DOM nodes and are some?
Okay, so in that case, your memory will probably be increasing. And in that case, you cut your code again. But if you really want, I mean, there would be, I think, I'm sure that there's an event type under, if you go to comparison, you go into or summary, you can probably find events in here and then go see the actual events. It's just like how you're doing it attached DOM nodes. You can probably see the number of events actually increasing. I think if we do it on timeline, I mean, to each, I think there's listeners, right? There's a listener.
Listeners, yeah.
There's a listener, so I mean, you could see listeners increasing. If your listeners are increasing infinitely too, then that's probably also an issue. How's everyone making out? Does anyone find it yet? Did anyone figure out where the issue is? Raise your hand if you've seen the, like what page that there is an issue.
Is it the artist list?
Yeah, it is. So you've seen an issue on the artist list
It's
page?
an issue on the artist list, yeah.
Okay, so
the code is
Seems
fine,
like
so
when
it's
you-
just a fundamental at first.
So yeah, so there is an issue on the artist page. Yep.
Each item is referencing, let's see, HTML artist. So the UI spread we call it album.
Mhm.
Is something that could be, because the artist controller is,
Oh.
JavaScript code is tiny, as small as it gets, right?
Yeah, actually, I fixed it locally, I think. Actually, yeah. Is yours like this?
No, it's ng.
My bad.
Okay.
So there was actually an issue with collection repeat. Apparently, I pushed it up to GitHub. I'm sorry for making you waste your time like that. That's awkward.
So you fixed it already?
Yeah, that's bad. Yeah, if you go over to collection repeat memory, there was a bug open, and we're trying to reopen it right now. So that's where the other issue was. My bad. But I mean, the whole gist of this like talk workshop is to show you how to find memory leaks, and also if you do have memory leaks. So does everyone understand how to like see if we do have a memory leak? Raise your hand if you don't. If you don't, then I didn't do a good job. I will come teach you after sometime. Okay, so everyone knows how to find a memory leak if you have memory leaks. And does everyone kind of know like the method I use to like figure out how to get where they are and stuff? Okay, cool. I think I still have like 2-3 minutes. If anyone has any like last minute questions, go over it really quickly.
One question of profiler, could you walk us through exactly how to decode this tree view So you look at so you detach DOM
Sure.
node. That's
Yep.
one of the more complex things I've seen. So
Yeah, no problem.
if you open it and if you just
Yeah, so let's go to detached DOM node right here. And right now there's no increasing, but if you see an increase, let's say there's 6 DOM nodes, and these have 35 entries. So this is all just HTML information. So if I go like hover over, let's find a good one. Oh, that's
so
not it.
these are entries that are inside DOM node. So
Yeah.
elementary HTML.
So yeah, this is all grouped together, like when it got all allocated at the same time. Just trying to find a good one.
That was my question. But how do you actually read this?
How do you read it? Oh, so basically, the way I read it, I mean, I see the object counts, and I try to like figure out when the object counts are increasing, and then I go inside and open it up and kind of just read the HTML. I mean, there's not really too much rhyme or reason to it, other than that this HTML is kind of grouped by some kind of order. Like, I don't know if it's directive based or something like that, but all these HTML and div elements are kind of like siblings.
Okay.
So
So you mentioned that could be like storing event listeners or
well, event listeners could have put like an event onto it, and then they don't get cleaned up, so this gets stayed in memory. Yeah.
so how about like would if you use jQuery for instance or just JavaScript to create a DOM element but didn't put it on the page and just stored it in a variable, is that going to be in this or just?
Nope, that's fine. If you create an element in jQuery, like a DOM node, and then you store it in memory, but it's not being used, Mark sorts go through and they find out if variables are referenced anywhere. That variable is not being referenced anywhere, right? So it's just in a variable.
Okay.
So that variable gets cleaned up, and then it's all good.
But as long as the variable is referenced, the actual variable is in the detached DOM tree.
Yes. Cool. All right, thanks everyone. Also, I know it's not the most exciting talk. Sorry if that was kind of boring.